Welcome to the video lesson for section 7.3, histograms and shapes of distributions. We're going to talk about what it means to be a histogram and how we can use it to represent data, and then how we can discuss the different types of distribution of data. Let's get started. To begin with, we're going to talk about what a graph could look like and how we can use that to summarize some of the data. For our first example, we have something that is skewed left, and we have an image of a cat here because we normally talk about the tail of a graph when it's skewed. If something is skewed left, we can see the tail of our cat is on the left. And if we equate that to our histogram, we can see that we have, again, the tail on the left, or the lower portion. We have this peak over here on the right. Now, since our peak is on the right and the tail is on the left, we would say that most of the data is on the right side. So if something is skewed left, that means the tail is on the left side, most of the data is on the right side. If we compare something that's skewed left to a symmetrical graph, we can see that we have a tail on both sides, but it's evenly distributed. So if we're talking about where the bulk of the data is, we would say it's definitely in the center of your graph or the middle. And then we move on to our skewed right data. The tail again is going to be on the right side since it's skewed right. And that's going to correspond with our histogram where we see the tail is also on the right, which means the bulk of the data is going to end up being on the left side. So one thing to kind of remember when we're talking about the skewness, that's where the tail is, where the peak is on the opposite side or the bulk of the data is on the opposite side. The next thing we're going to examine for our graphs is which measure of center would be best. For our two skewed graphs, the tail is going to drastically affect the mean. If the tail is on the left side, it's going to pull the mean towards the left side, which means the mean would be less than the typical value. On the opposite side, if the tail is on the right, then the mean gets pulled towards the right, so your mean would be higher than a typical value. So since the tail is affecting our mean, when we're talking about the best measure of center, we would instead use the median. When you look at a symmetrical graph, we can see that we don't have a tail, so the mean is not being affected, which means when we're talking about the best measure of center for a symmetrical graph, we would use the mean. And then the last thing we want to use when we're talking about our graphs is the best measure of spread, talking about how things are distributed or spread out. Again, because our mean is affected by our skewness or by our tails, we would want to use something that is unaffected by that when we're talking about the measure of spread. So we're going to end up using our 5-number summary, which is the same thing we use for our box and whisker plot. We would find our minimum, our quartiles, and our maximum, again, for your skewed graphs. When you have a symmetric graph, you're going to end up using the standard deviation, and that's something we'll be talking about in the next lesson. And we'll be using that to talk about the best measure of spread or variation for our graphs. For our example here, we have a frequency table over on the right here, and that represents the frequency for the number of pounds of aluminum cans collected by a class. What we're going to do is display the data as a histogram, and then we're going to describe the shape of the distribution. Before we can talk about what the shape looks like, we have to draw a histogram. And in order to draw our histogram, we have to understand how to label our graph. So for our graph, your frequency is always going to be going for your y-axis, whereas the number of pounds is going to end up being your x-axis. So the variable that we're talking about is usually going to be your x-axis, whereas the frequency is almost always going to be your y-axis. So I'm going to go ahead and sketch our histogram and then discuss how I got that. So I went ahead and labeled axes. I have our x-axis going from 0 to 60 to make sure I can express the correct number of pounds. And then to represent my frequencies, my y-axis is going from 0 all the way to 40. I'm going to go ahead and draw in my columns now. Our first column is going to represent the number of pounds from 1 to 10. It's going to have a frequency of 7. So I'm going to draw a column that's going to go up to 7, maybe a little bit higher than that, and it goes over to 10. For my next column, I'm going from 11 to 20, and I'm going to go all the way up to 8. Now, because it's 11, it's not starting at exactly 10, so there should be a little bit of space in between my histograms, and I'm going to try and make sure that I do that. So I'm going to go up, over, fill that in. It's a little bit higher. And then I have from 21 to 30 going all the way up to 10. Then we have from 31 to 40 going up to 16. '41 to 50 goes all the way up to 34. And then for our last histogram, 51 to 60 goes up to 15. Again, looking at our ranges, they aren't actually touching. I have 1 to 10 and then 11 to 20. So you can see there is a small space in between my histogram columns. But the height of my column is always represented by the frequency that I have from my table. When I'm describing my shape, I can see that the bulk of my data is over here on the right side, which means my tail is on the left. And since the tail is on the left, I can say this data is left skewed. For this example, we're going to go ahead and describe the shape of the box and whisker plots, and then we're going to decide based off of the shape what would be the best measure of center to use. For our first example, if I look at my two whiskers, I see that one whisker is definitely longer. The one on the right is much longer than the one on the left. And the longer whisker is going to help us identify where our tail is. Since our tail is on the right, I would say this is definitely going to be a right skewed box and whisker plot. And since it's skewed, I would definitely use the median as the best measure of this box and whisker plot. For our next example, if I look at my two whiskers, they are pretty much the same, meaning this is more of a symmetrical box and whisker plot. And when we have a symmetrical graph or box and whisker plot, we would use the mean as the best measure of center. For our next example, we're going to be comparing two histograms and talking about the shape and the appropriate measure of center for each one. For our first histogram, we can see that there definitely is a tail over here on the right side. And since there's a tail over here on the right side, it's going to be skewed. And as we saw with our last example, anything that is skewed, we would use the median as the best measure of center. For our second histogram, we can see that even though it's not perfect, we have roughly the same amount of data on both sides, meaning there is no tail, and this is more of a symmetric histogram. And since it's more symmetrical, we would definitely go with the mean as the best measure of center. For our example here, we have the data that shows the last 24-hour ATM withdrawals at a bank. We have a couple questions here. The first question is that we want to display the data, but we have to create our own frequency table using intervals starting at 26 to 50. We're then going to use that to create our histogram and talk about which measure of center and variation would be the best. And finally, we'll answer question C, which talks about the bank charging a specific amount. All right, to begin with, we want to look at how to set up our intervals. Since our first interval is from 26 to 50, I want to figure out what that actual length is. By subtracting our two endpoints for our interval, 50 minus 26, I get 24. So know the distance for my intervals is always going to be 24. I'm going to go ahead and start by writing my first interval, 26 to 50. For my next interval, it's going to start at 1 higher, so it's going to be at 51. And I know I'm going to be adding 24 to that, which would end up at 75. And I'm going to continue this pattern. So I would then go from 76, adding 24, I would get to 100. And I'm going to use this to continue getting the remaining intervals that I need. And notice I'm going to have 7 intervals. I'm also going to make sure that I go until I get up to a value of 200 because that's my highest value. All right, now that I have my 7 intervals, the next task I need to do is I need to organize my information by frequencies. So I'm going to look at my table and try and determine how many of these 24 numbers are a value between 26 and 50, and I'll put my frequency right next to it. I'll do the same thing for the interval 51 to 75. I'll figure out how many numbers there are in my table that are between 51 and 75, and I'll put that frequency next to that. So why don't you pause for a moment and try and figure out the frequencies for each one of our intervals, and then check back in and we'll see how you did. All right, so you can see here that I've gone and found all of my frequencies. There were 7 numbers that were from 26 to 50, 5 numbers from 51 to 75, 5 numbers from 76 to 100, and so on. And I try to color coordinate how I cross things off on my grid here. I also went ahead and labeled my x-axis. So it's going to be the values from 26 all the way up to 200. So I have going by 50s here for my axes. For my y-axis, I'm going to go by 1s because my frequencies aren't that high. I'm going to go ahead and create my columns now using my information here. I want you guys to go ahead and do the same thing. So why don't you pause and then come back and check your answer. One thing to note here is I do want to comment on our labels here. Since we're talking about the amount of ATM withdrawals, I've labeled that for my x-axis along with my values for my x-axis. And then my frequency is my y-axis, so I label that as well. All right, so you can see here I have my histograms representing my intervals. So for the interval 26 to 50, there were 7 frequencies, and you see that my column goes up to 7. For 51 to 75, I had 5 values, and my column goes up to 5, as it does for my next interval from 76 to 100, and I have all of my other columns represented as well. All right, we can move on to B now. So B says, which measures of center and variation would best represent the data and explain? I can see that there is a tail over on the right side. So this is a right skewed graph. Because there is a tail, we would use the median as the measure of center when describing the graph. Since it's skewed, we would also use the 5-number summary when we're talking about the variation for the graph. And lastly, for question C, the bank charges a fee for any ATM withdrawal less than $150. How would you interpret that data? We can see that at 150, there are only 2 withdrawals that are over that. Every other withdrawal is below that, meaning that there are 22 withdrawals less than 150. If the bank charges a fee for an ATM withdrawal less than 150, then that would mean that there were 22 different fees for the withdrawals here. All right, guys, that does it for notes for this section. Go ahead and get started on your homework. Good luck.